So now we're going to use the shifting property and a couple of identities that we've already seen before in order to find the Fourier transform of the sine and cosine. So I've drawn out here the shifting property which we've seen before. So if we had a function of time, let's say it's the impulse function delta t, whenever we Fourier transformed that we get a value of 1 which went off to minus infinity and plus infinity in the frequency domain. Now when we shifted that function delta t to a new point t0, then we'd be left with this function delta t minus t0, and whenever we Fourier transformed that, we would have this value here, which is e to the minus I omega t0, which would be a phase shift. So what's happening is all these little phasors are getting shifted along in the imaginary axis. So we're left with the transform pair delta t minus t0 is e to the minus I omega t0. So let's use that and a couple of identities which we'll see in the next slide in order to work out the Fourier transform of the sine and cosine. So if we take our impulse function and we delay it in time, in the frequency domain it's equivalent to adding linear phase, so you get e to the minus I omega t0. Now we've seen whenever we looked at the impulse function, you can do the same thing in the frequency domain. You can take a signal which is an impulse function in the frequency domain delta omega, you could delay it by a frequency value of omega naught, and that's going to be equivalent to in the time domain a delayed or a phase delay of e to minus I omega t naught. So you would get this transform pair here. So we derived this in a previous video. Equivalently, if you were to change the delay from minus omega naught to plus omega naught, it gives you e to the minus I omega naught t. So these two little Fourier transforms were worked out previously. Now using these and the two identities, now these two identities again, we've seen these in one of the first 2 or 3 videos we did. It's the identity that cos omega t is a half e to the minus I omega naught t plus a half e to the minus I omega naught t, and the sine omega naught t is 1 upon 2i e to the I omega naught t minus 1 upon 2i e to the minus I omega naught t. Again, if you're unsure of those, have a look back in the previous videos. We derived those graphically, and we've seen them in the graphical calculator as well. So we can say here then that in order to find out what the Fourier transform of our cos omega t is, we simply need to have a look up here and equate all of these terms. So if we had cos omega t, we see it's going to be a half e to the minus I omega t. Okay, so it's only going to, this is e to the minus I, e to the I omega t here, so it's only going to be half of this value, so it's only going to be the 2 pi delta omega minus omega naught over 2. Okay, so you're just going to be left with a pi delta omega minus omega naught, and similarly with the second term you'll end up with pi delta omega plus omega naught. So the Fourier transform of cos omega naught t is this little function here, which is two little impulse functions separated by plus omega naught and minus omega naught of height pi. Now you can do the same thing with the second identity here, the sine omega naught t, and if we note that division by I is equivalent to multiplying by a value of minus I, so you work through the little bit of maths there, you get the sine omega naught t is given by Fourier transform, it's given by minus I pi delta omega minus omega naught plus I pi delta omega plus omega naught. We get that plus term because the I comes up and it becomes a minus, so the two minuses cancel out. So these are our little transform pairs here that we've been looking to work out. Now what we'll do is we'll go and have a look at these graphically, and we'll also go and look at them in MATLAB. So this is the Fourier transform of the cosine function done graphically. So we have a function here cos omega naught t. It's a real even function, so it maps through the cos omega t surface onto the frequency domain. In the frequency domain it's got two impulse functions, one at plus omega naught, one at minus omega naught. So the two functions are height pi, so you get a pi delta omega minus omega naught and pi delta omega plus omega naught. So the Fourier transform of cos omega naught t is pi delta omega minus omega naught plus pi delta omega plus omega naught. So let's go and we'll look at the sine function. So here's the sine function here, it's sine omega naught t. It's a real and odd function, so it maps through the sine omega t surface onto the frequency domain. It's got two impulses here, both are purely imaginary, one at plus omega naught, one at minus omega naught. So we get the Fourier transform of sine omega naught t is minus I pi delta omega minus omega naught plus I pi delta omega plus omega naught. So let's go and we'll have a look at the outputs from MATLAB for these. So this is the output from MATLAB for the cosine function. So the cosine function, the time function is in the bottom, and it's been Fourier transformed, and you can see it's a purely real function, and it's got two impulses, one at plus omega naught and one at minus omega naught. So let's have a look at the sine function. So here's the sine function here, the time domain in the bottom and the frequency domain in the top, and you can see it's a purely imaginary function, and again you get these two impulses here. So let's have a look at it live in MATLAB. So we'll use this function again, f1, and we'll be able to produce our cosine function here. And again, these are available in the resource section in the text file. So let's have a look at that. So that's just as we expected to see. We've got our two little impulse functions, and they're purely real. Okay. Now we'll go ahead and we'll look at the sine version. So again, we've seen this one in the previous slide, and this is again the two impulse functions, but they're purely imaginary, and one is in the positive direction, one is in the negative direction. So that's as we expected to see. So let's finish off by looking at the frequency domain. So if we were to have a cosine function in the frequency domain, then whenever we inverse transform it, we get two impulses in the time domain. So cos omega t be given by half delta t minus t naught plus a half delta t plus t naught. And similarly with the sine omega t naught, we would have a half I sine delta t minus t naught minus a half I delta t plus t naught. So that's all there is for the sine and cosine. So we'll move on to something else in the next video. Okay, thank you. Goodbye.